Welcome back to Sarrawy Dev. Take a look at this controller. If this is how you are still validating your user input in .NET, by stacking endless if-else statements right inside your endpoints, you need to stop doing this right now. This is cluttered, hard to maintain, and it completely ruins your clean architecture. In this video, we are going to completely wipe out this messy code and refactor it into a modern high-performance minimal API using Fluent Validation in .NET 10. Let's jump in and fix this. To get started, open up Visual Studio and create a new project. Select the ASP.NET Core Web API template, and let's name it Fluent Validation Demo. Keep the solution organized, choose your directory, and let's hit Next to configure our framework. Now for the additional information, make sure to select .NET 10.0 as your target framework to take advantage of the latest features. Also, keep Enable OpenAPI support checked so we get Swagger configured out of the box. Now that our project is ready, let's install the necessary packages. Right-click on your project and select Manage NuGet Packages. Under the Browse tab, search for Fluent Validation. So let's select it and hit Install. Next, let's search for Swashbuckled ASP.NET Core to add our Swagger documentation support. Click Install, accept the licenses, and we are officially ready to clean up our code. With our packages installed, let's start structuring our application. First, create a new folder named Models to keep our code clean and organized. Inside this folder, let's add a new class and name it User Registration Request. This class will act as our data transfer object to capture incoming request data. Let's define our properties: full name, email, and password as strings initialized to empty, and finally, an integer for the user's age. Perfect, our data model is ready. Now, let's build the core of Fluent Validation, our validation rules. First, let's create a new folder called Validators to keep things decoupled and clean. Inside, add a new class named User Registration Validator. To turn this into a validator, we need to inherit from Abstract Validator and pass our user registration request as the generic type argument. By doing this, Fluent Validation maps this class directly to our model, giving us access to a powerful Fluent API to write clean, strongly typed rules inside the constructor. Let's open up the constructor and write some rules. First, for full name, we ensure it's not empty and chain a minimum length of 3 characters, passing a clean custom error message. Next, for the email, we check that it's required, and instead of writing complex regex manually, we simply use the built-in email address method to validate the format instantly. For the password, we enforce a minimum length of 8 characters. Then we chain the matches method with regex to guarantee it contains at least one uppercase letter and one number for strong security. Finally, for the age, we can use inclusive between to easily restrict the registration age to be between 18 and 60 years old. Now, let's head over to Program CS to stitch everything together. This is where the beauty of minimal APIs truly shines. To get our interactive API documentation up and running, we need to register 2 essential services. First, add Endpoints API Explorer. This tells .NET to explore and map out the metadata of our minimal API endpoints behind the scenes. Right after that, we call add_swagger_gen, which takes that metadata and uses it to automatically generate the beautiful Swagger UI and OpenAPI specification for us. Next, we need to register our newly created validator into the Dependency Injection container. We do this by calling builder services.AddScoped. We pass the IValidator interface typed with our request model and pair it with our concrete user registration validator class. Inside the isDevelopment check, we call app useSwagger to generate the OpenAPI specification file and app useSwagger UI to actually spin up the interactive web interface. Now, let's write our modern, lightweight endpoint. We call app mapPost and define our route as /API/register. Look at the Lambda parameters here. We simply type our user registration request, and right next to it, we inject our IValidator interface. .NET's built-in dependency injection will automatically provide our validator instance right here. Inside the endpoint, we execute our rules asynchronously by calling await validator validate async and passing the request. If the validation fails, we don't manually parse errors or write dirty code. Instead, we return results validation problem, passing validation result to dictionary. This is a massive win because it instantly builds a standard, RFC-compliant error response that front-end developers and mobile apps absolutely love. If the data is perfectly valid, the code execution continues seamlessly, where we can place our database logic later, and we return a clean results with a success message. Finally, we chain with name to give our endpoint a distinct identity. Look at that. A fully validated high-performance secure endpoint in just a few lines of clean code. Let's hit the Run button and see this in action. Visual Studio spins up our application, and thanks to our configuration, Swagger UI opens up. Perfectly in the browser. Let's expand our /API/register post endpoint and click Try it out. First, let's intentionally send some bad data to test our validation rules. I'll set the full name to ed, which is under our 3-character minimum, provide an invalid email format, set a weak password as 123, and change the age to 12. Let's hit execute. Look at that gorgeous response. We get a clean 400 bad request, but more importantly, look at the structured validation problem output. Every single field has its exact custom error message mapped out perfectly in a JSON dictionary. Now, let's pass completely valid data to see how our API behaves when everything goes right. I'll change the full name to Sarrawy dev, use a valid email address like channel@sarrawy.dev, set a strong password as secure password 10, which hits all our uppercase and numeric requirements, and finally, set the age to 30. Let's hit execute. And there it is. A clean 200 OK status code, and we get back our structured success response, user registered successfully. Our minimal API completely isolated the validation logic, kept our endpoint incredibly clean, and handled the request flawlessly. And that is how you implement Fluent Validation in .NET 10 using minimal APIs the right way. As you saw, our endpoints remain incredibly thin, high performance, and entirely decoupled from the validation logic. No more messy conditional blocks inside your business code. Thank you so much for watching, and I'll see you in the next video. Happy coding!